And in this session, we are going to see about the effect of dielectric on a capacitance. In the last previous video, we have seen only the how the capacitance is related to area and distance between the plates. Now, we are going to replace that air medium or vacuum. Instead of that vacuum or air medium, we are going to place one dielectric. So what will happen in the sense, I'd say the result right now. Afterwards I will explain how it happens. If you are inserting a dielectric between the two parallel plates, it will increases the capacitance of a capacitor. Right, now we are going to briefly for this section when there is a vacuum before the plates. So as we know that from the last previous section, E naught is equal to sigma by epsilon naught, that I mentioned as equation number 1. And similarly, the potential difference between the plates V naught is equal to E naught into D. Therefore, the capacitance of a capacitor I can mention as here C naught. All those indicating about these E naught, C naught, all is indicating about is vacuum or else air medium. So C naught is equal to Q by V naught. Therefore, I can written as epsilon naught A divided by D, that I mention as equation number 3. Suppose a dielectric is placed between the plate fully, right? So what will happen? So if you are applying an electric field to a dielectric, so electric field is reduced by the polarization in dielectrics, right? So as I mentioned is clearly, as we know that the electric field is reduced by the polarization in dielectrics. Due to this polarization can be done by the induced dipole moment, right? So from that the field will be get reduced. Therefore, net charge surface density on the plates is sigma minus sigma p. As we know in the previous section, E total electric field is, we have written as E minus EP, right? Similarly, we can write here the total surface net charge as sigma minus sigma p. So from that we can write electric field E is equal to sigma minus sigma p divided by epsilon naught. Why? In the sense, as we know that the electric field E is equal to is related to surface charge density divided by permittivity of free space. Instead of sigma, we are going to write sigma minus sigma p. And the potential difference across the plate we can written as V is equal to E into D. So instead of E, we are going to use this term sigma minus sigma p divided by epsilon naught into D. So E is equal to sigma minus sigma p divided by epsilon naught. For linear dielectrics, this net surface charge density is directly proportional to net charge density, right? So sigma minus sigma p is directly proportional to sigma. If you are removing this direct proportional, we need to add one constant. That constant we are including here as 1 by k. So sigma minus sigma p is equal to 1 by k into sigma, where k is called dielectric constant. And we are going to calculate now the potential difference between the plates. V is equal to sigma minus sigma p divided by epsilon naught into D. As sigma minus sigma p can be written as sigma by k from the last equation number 6. So left we have 1 by epsilon naught D, and we have sigma as we can written as q by a, right? So sigma can be written as q by a from the definition. So instead of sigma, I can written as q by a into 1 by this k epsilon naught, and here we have D. Then the capacitance of a capacitor C within the dielectric between the plates I can written as C. C is equal to q by V as a definition. So it is equal to q. What is V value we have found here? QD divided by A into K epsilon naught. So Q into D divided by A into K epsilon naught. So this Q and Q will be cancelled. The denominator of denominator should goes to numerator. So we can written as A K epsilon naught divided by A. So when the capacitance of a capacitor, when we are inserting the dielectric medium, if area increases and dielectric constant increases, this capacitance value increases, and if D is increases, this C value becomes decreases, and this C is mainly depends upon the dielectric constant when we are inserting a dielectric medium. That's why I am telling, when we insert the dielectric medium, so that dielectric medium increases the capacitance value directly proportional. Here C is directly proportional to K. The product of epsilon naught into K is called permittivity of the medium. This K into epsilon naught is called as permittivity of the medium, and it is denoted as epsilon naught. So I can written as epsilon is equal to epsilon naught into K. Suppose if the medium is vacuum, K becomes 1 and epsilon is equal to epsilon naught. From that we can conclude the definition for dielectric constant, K is equal to epsilon by epsilon naught, where epsilon is permittivity of the medium and epsilon naught is permittivity of free space or vacuum. And from that equation number 3 we can written as C naught is equal to epsilon naught A whole divided by D. From that equation number 8 we can written as C is equal to AK epsilon naught whole divided by D. So this D will be cancelled, epsilon naught will be cancelled, and A will cancel. That will give us 1 by K. So C naught divided by C is equal to 1 by K. From that we can rearrange. This K can be go to this side and C can be go to this side and C naught go to this side. So K can be written as C by epsilon naught. From that equation we can conclude the capacitance of the dielectric is increases. Obviously the dielectric medium is also, dielectric constant is also going to be increases, or otherwise if dielectric constant K is increases, this C will be the capacitance of a capacitor when a dielectric medium is increases. Thank you.